Okay, so we are beginning our next unit, which is scientific measurement. And scientific measurement has some math involved, but the math isn't too hard. It has measuring like mass and volume and length and width and temperature. Um, and for the sake of the schedule this year and the fact that I want to get you into the lab as soon as possible, we are, that's fine, Grant. We are going to start with an activity called calorimetry. And a calorimeter, a calorimeter apparatus is here. There's a can, there's some water in it. There's a little snack sitting on a pedestal, and there's a cork. It's got a aluminum foil and a little dish. And then we light it on fire, and we measure the heat output, the heat that gets transferred to the water inside, and it can be used to measure calories. Now, so that you start thinking about some ideas right now, what I'm going to ask you in the end today, we are all going to use one snack, and it's going to be the same snack, a snack that nobody is allergic to. And your challenge is going to be to take this design and modify it to get maximum heat transfer and little heat loss. We don't want our heat lost to the environment, and we want that heat transferred to the water inside the can. So this is a basic setup. You're going to end up building something, and the only thing that is required to be there is aluminum can. It has to be an aluminum can, and it has to have water in it. So that has to be one constant. So I'll let you watch this video, and then I'm going to ask some questions.
6 snacks, and they are lined up, each in individual calorimetry units. Calorimetry is used to determine the number of calories in a substance, or to just measure energy changes in reactions. So what we see on each of the calorimetry setups is a pedestal with a snack, the calorimeter which has water in it. And the goal of this activity is to just make comparisons between 6 different snacks and predict which of these snacks will produce a data set that is most consistent, where the measurements are all showing levels of precision or very close to each other. So our snacks include a walnut, a peanut, puffy Cheeto, a regular Cheeto, a cashew, and a potato chip. In the next segment, this setup will include all of the snacks ignited, and you can compare the flame qualities of each.
Okay, my first question for you is going to be, I have to exit out of here and go to the next slide, is going to be, which snack do you think is releasing the most energy and why? So we're going to watch the snacks go. If you're not in the Pear Deck right now for Wi-Fi purposes, please answer in the chat if you can. So which snack do you think is releasing the most energy and why? So I'll continue the video. And we have a potato chip, a walnut, a peanut, a puffy Cheeto, and a regular Cheeto.
The potato chip is burning brightly with a flame that is kind of wavering all over the place. The flames are creeping up onto the can. The cashew is burning with a very pointed flame. It appears that the potato chip just fell. I think there might be a safety issue there. I'm gonna let it keep going. The cashew is burning with kind of a pointed flame. The peanut is also burning with a relatively pointed flame up at the base of the can. The walnut has flames flickering to and fro. You can see that there's a lot of energy coming off of it. I may have to reignite some Cheetos because I had them go out. In the meantime, you can see that all 3 nuts are burning for quite a while. and they continue to burn. The cashew flame looks a little wider now. The peanut flame still very pointed underneath the can. The walnut has a very wide flame, and a lot of this has to do with the nature of the shape of the snack to begin with, what sort of flame properties it might have. I will blow these out. I will reignite 2 Cheetos, and you can see comparisons between those two. And here I have the Cheetos burning. The cashew is still burning. I'll get it from different angles. So this is the regular Cheeto here. I'm sorry, I have dirty fingernails from cleaning the soot off all of these cans today. The puffy Cheeto appears to be producing quite a vigorous flame. It's not centered right now. I'll center it, actually causing flames to lick up along the sides of the container. So the question was, so which is producing the most energy? After seeing these Cheetos burn, you may end up changing your mind. You may not. There are reasons I would, and there are reasons I wouldn't. I'm just kind of thinking what you guys are thinking. Let me share some of the things so far. Somebody said the puffy Cheeto with the biggest flame. The walnut, because of its shape. The chip is releasing more energy because there's most fire. The walnut, because I've heard they have lots of fat and it makes them filling. The puffy Cheeto, biggest flame. The walnut has bright and a large flame, which indicates more energy is being released. I like the thought process. Potato chip with the biggest flame. Some people said waters or walnuts again. So those 5 of you have not responded to this. So I am going to want you to, Landon, Matthew, and Grant and Christopher. I think Grant, I know you're having problems, but I want you to tell me which of these you think has the biggest energy, which is releasing most energy. Container, the regular Cheeto is burning with a little bit more pointed flame, perhaps because it's more dense in general. There's a lot of fat in the snacks. You can see that the amount of time that it takes to burn a Cheeto is significantly less compared to the nuts. The puffy one is out already, and this one is close. There's some fat dripping. Some of that fat kind of flickers and falls a little bit with the flames. That's so cool. This could be a good activity on a date if you want to introduce romance into your activity of flame, kind of like candlelight, but Cheeto light, or maybe not. All right, so the goal of this is to predict which of these snacks. Okay, I'm going to stop there. I'm going to turn on my whiteboard for a second, and I just want to indicate a couple of things. Share whiteboard with this setup. And again, the goal is going to be for you to build a contraption that maximizes the amount of heat going to the can with the water in it. Everyone will have a can, an aluminum can. You'll have to have some sort of base for the snack to sit on. In this case, it's a paper clip shoved into a cork, and then the snack sits on top of it right here. And then we light it on fire. And some of them have the flame just really centered in the center there, creeping up here. Some of them had the flame coming out the sides, coming up along the sides. So there's an assumption that we make with calorimetry, and it's a bad one. That assumption is that all of the heat released by the burning snack
is absorbed by the water, is transferred to the water? Shoot. I should have had a Pear Deck question that says, tell me in the chat, please tell me, why is this assumption wrong? It'll have to be in the chat. It can't be the Pear Deck anymore. I don't have a question for it. Why is the assumption wrong that all of the heat released from that burning snack is being transferred for the water? So please respond to this in the chat. You can respond privately or you can respond to everyone. I agree, Emily. I agree, Madeline. Zach, I also agree the can is getting some. The can is absorbing some. So let's have heat be it's gonna be red, I guess. So the assumption is that all of the heat is going to the water in the can, but some of it is going to be absorbed by the can itself. And some of it's going to go out into the air. And some of it will go into the water, but then it'll go out into the air this way. So again, we want to design a system that prevents heat loss. We want to design a system that allows the channeling of this heat to the water in the can, the retention of that heat there, or to have that heat be retained. We want to maybe somehow block this heat from leaving the system. So the next question on the Pear Deck is, which snack do you think is losing the most energy to its surroundings and why? So which snack do you think is losing the most energy to its surroundings and why? So I'll bring this back. We'll watch them burn again.
That is kind of wavering all over the place. The flames are creeping up onto the can. The cashew is burning with a very pointed flame. It appears that the potato chip just fell. I think there might be a safety issue there. I'm gonna let it keep going. The cashew is burning with kind of a pointed flame. The peanut is also burning with a relatively pointed flame up at the base of the can. The walnut has flames flickering to and fro. You can see that there's a lot of energy coming off of it. I may have to reignite some Cheetos because I had them go out. In the meantime, you can see that all three nuts are burning for quite a while. And they continue to burn. The cashew flame looks a little wider now. The peanut flame still very pointed underneath the can. The walnut has a very wide flame, and a lot of this has to do with the nature of the shape of the snack to begin with, what sort of flame properties it might have. I will blow these out. I will reignite two Cheetos, and you can see comparisons between those two. And here I have the Cheetos burning. The cashew is still burning. I'll get it from different angles. So this is the...
So 9 of you haven't responded. The question is, which of these snacks do you think is losing the most heat to the surroundings as opposed to that heat being transferred directly to the can, and why? So which is losing the most heat to the surroundings rather than being transferred directly to the water in the can. So here are some thoughts. The chip, because it fell off, it's not flaming into the can anymore. The puffy Cheeto, because its flame is irregular, tends to point away to the outside of the can, which would make that energy travel outside the can. So right, anytime you're getting lateral flickering of that flame, that heat is being projected that way. So with that flat chip, you had heat really just all that surface area, which some of you mentioned, is more space for the heat to leave, as opposed to the more pointed flame is really channeling that heat. It's slow, it's steady, it's not as big of a flame, but it's probably transferring more of its heat to the can than those wide and spontaneous flickering ones are. So the next question is, what snack do you think will produce the most consistent set of results for a large number of trials, and why? What this means is, which of these do you think will burn in a very similar way each and every time, and have the heat be transferred very similar each and every time? What snack do you think will produce the most consistent results over time, and why? So many of you are mentioning the peanut because of that consistent shape and size. And I would agree. Most peanuts are about the same size. Not only that, but its shape, its round shape, and some of you mentioned this, will have that flame pointed the same way, as opposed to like the walnut. The walnut with its wide shape might sometimes result in more heat loss to the surroundings compared to others. So sometimes you might be having more heat loss in one trial compared to another. So most of you said peanut, and I agree that it would be the peanut. I have several of my students this year with peanut allergies, so we will not be able to use a peanut. I'm trying to figure out which snack we'll use. If we have allergies to nuts, any nuts at all, besides peanuts, then we'll probably use a puffy Cheeto. Do I have, which snack do you think would be the best to use for high energy output and consistent results, and why? I should have said the worst. I'll show some of the responses. Several of you said potato chips. I disagree with potato chips because we want a consistent result and one without a lot of heat loss. So the potato chips are probably going to lose a lot of that heat and also be very inconsistent. And it burned out really quick. So Um, so a lot of you are really, oh, I don't know what happened. A lot of you are really consistent with this. I'm going to go to the next, even though some of you didn't answer yet. I just want you to think about this overnight. Um, so you're going to be challenged to modify that simple calorimeter so we can minimize heat loss to the surroundings. We need to contain it, maximize the heat transfer from the burning snack to the water in the can, allow for enough airflow so that the snack can burn. You can use any supplies to build your calorimeter. However, you must have an aluminum can holding the water. That is the one constant we all have to have. And you're welcome to use any of my lab equipment that can be found in the classroom, as well as any additional supplies you bring from home. So I just want you to start thinking about how you might build a contraption to really contain that heat and have it be transferred. I'm going to have you work in teams. In the team, you'll probably have to work in a breakout group tomorrow to make a plan. I'm hoping that we can bring supplies in on Monday and actually start building. We're all going to use the same snack, and we'll compare our results to each other's and see if one group setup was more effective at trapping the most heat. So we'll try to figure out whose is the most effective at doing what we're trying to get it to do. So that's all I have for today. There's no homework in addition to this. I'm going to stop recording now. I'll see you guys later.